Yo, 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 what's up? Good morning. So, this will hopefully be quite an interesting session. I've been looking forward to this ever since yesterday. So, just to recap real quick, we're tessellating the snow mesh. We are identifying the quote unquote new vertices, and we're offsetting those based on age. So, you get fading instead of popping when the mesh tessellates one more degree. We have it working for most vertices. The diagonal vertices, so the vertices located in the middle of a diagonal line, so the line that triangulizes a quad. It doesn't work for that because we don't know if it's bottom left to top right or top left to bottom right. But we want more control over how a quad is triangulized because we want to be able to flip them to create smoother edges, basically. So that's what today's stream is going to be about. We're going to try and triangulize quads in a way we want them. And I think we have a few different approaches to this. So one is handling it in the domain shader, I think. Or we can do it in a geometry shader, which in the geometry shader, I'm certain it will work, but it's going to be a bit more complicated than I initially thought. So a geometry shader, it can't take quads as input. It has to be point, lines, triangles, or line adjacent or triangle adjacent. And if we take a look here, we can see what that means. And sure, we would like to get quads, but we could also work with triangle adjacent. But there's one thing that makes that impossible for our case. And that's the fact that when you work with adjacent, we should have, let's see if we can find it. Here, a geometry shader that expects primitives with adjacency is not valid when tessellation is active. So if we want to use tessellation, we can't use adjacency in the geometry shader. But that's okay. So it just makes it even harder again. But basically, what we work with during tessellation are quads, and then we either triangulize them like this or like this. And that's what we want to control. We want to control if it triangulizes as this or this, right? But in our geometry shader then, we would get, so for a triangle like, or a quad that is split like this, we would be getting this one in one iteration of the geometry shader, and this one in the other iteration. And if we would like to split this, it's doable. We would pretty much have to add, we would have to calculate the missing point. So if we get a triangle in like this, we would calculate this point. And then we have full control. So from the output of the geometry shader, we could choose to output a triangle created from these 3 points or a triangle created from these 3 points. And if we would like to subdivide once more in the geometry shader, it would be a bit more complicated. For instance, if we would just, if this is the triangulation we want, we could subdivide this one, and this one, and we would pretty much get these 4 triangles. But if we choose to flip the edge in the middle, we would have to triangulate it as, or is it this, and this, I think. And something like that. And we want to do this, and then we would do this. So we would get the 4 triangles like this, basically. So this is the last resort. So last resort is going to be to do it in the geometry shader. I would like to avoid doing it in the geometry shader. But it's doable. So if we take one step back, I was very optimistic about the geometry shader yesterday, but that was before I had seen the limits that we can't work with quads here. Another thing you could do with the geometry shader is that when we subdivide, we actually only output points. So we output the point in the middle of whatever quad we have. So if we have a mesh like this, we output this point. So then in the geometry, we pretty much want to recreate quads using the middle point. But that means that for each quad, we're going to have to calculate 4 new points. I think that's okay. Or it could even be as many as over 8 points. And that would give us a lot of control. We would need to know this distance, so like what subdivision do we have, and things like that. But honestly, I think that would be okay, and this could probably be even better than this could probably be even better than this approach. Once again, this is in geometry shader. And then the drawback as I see it for doing it like this, depending on how complicated we make calculating each point, fuck, maybe this is the best, but depending on how complicated we make calculating each point, we're gonna have to, so like for each, or these 8 points, we're gonna calculate them more than once. This point, for instance, we're gonna calculate 2 times. Once for this point, once for this point. This one, we're gonna calculate 4 times. But I mean, we are basically doing a lot of that already because we calculate these points to be able to properly set the normal for this one. The problem being, of course, right now we calculate these normals once and then we use them here. If we generate it like this, we're going to have to calculate normals for these as well, which means even more neighbors. And yeah, it just becomes a question of performance then. Yeah, it's unfortunate. Then again, this is one approach we can take. We'll see what we get to. The first thing I want to try, however, is that in our domain shader, we actually get 4 points. And I wonder what would happen if I'm a little bit afraid of this. So what would happen in our domain shader? We get this as input, maybe. We only get the points. What if we notice that the current triangulation is wrong? It doesn't really work. Or it gives a suboptimal result. What if we would swap these 2 points? So whenever we calculate the position for this one, we actually set it to the position of this one. That's not entirely... Yeah, I don't know if we can do that. Because basically in our domain shader, let's see, we calculate it per point. It's just that we use the neighboring points. Maybe this isn't that. So it's, for instance, in a domain shader, we calculate this point. And if we would flip these points, if we would move this point to here, what would happen to connected vertices? Then we would basically flip this one as well, and we might destroy this quad, I think. Definitely don't want to do that. So yeah, I think it's these 3 approaches we have, unfortunately. Now it's just a question of how we want to do this. Yeah, it's gonna... So basically, if we want to calculate the normals for these as well, we are gonna have to do normal calculation for... We could try the performance of this one, but... So if each geometry shader gets a point, and from that point we calculate 4 quads, i.e. 8 triangles. The good thing is that we then know which points are the new ones. So it's going to be this, and we can adjust them accordingly pretty nicely. Hmm. So if we tessellate this mesh, we have 4 points initially. For this one, we would be recreating this, 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 and for this one, we would be recreating this, and this as well. And that's our quad. And then what would happen if we subdivide this one is in the tessellation shaders, we get these 4 points. So for this one, we would calculate these points. For this one, we would calculate these points. It's a lot of calculations. Unfortunately. But this would give us total control. Actually, I wonder if we have a better way of doing this. Yo, what's up, Bruce? Watch video about voxel terrain yesterday. Guy was using Octree. I would probably... I've seen it being mentioned. Haven't looked that much into it. But it's for... I don't actually know that much about it. Oops, let me ban that bot. Care to summarize it real quick if you can? Thank you for the link. I'm gonna watch it after today's stream. Did he do any quad flipping or anything like that? I would say if we would go with the point, if we would get points as input for the geometry shader and then generate quads from that, we're gonna do it by 8 neighbors. I mean, my understanding of Oct3, never worked with it, basically never read about it, seen it being mentioned. But I guess we're doing something similar, but we don't take the Z or dy into account exactly how one should, but we'll see. Like, this would work. I'm just questioning the performance of this shit. Same first time I heard about it. Yeah, I did some, when we started doing the terrain for this game, it was for summer last year. I read around on the internet a tiny bit and saw it being mentioned a few times. That's pretty much my experience, but I will definitely check out that video after the stream. Fuck, I'm thinking about this solution. It's all about uranium quite slowly. Define the stages and I can answer that question. My only question with doing it like this is how to handle the normals at these points. Are you using Unity? Yes, I am. Yes, I am. To calculate the normal for this one, we would need the connected vertices, which is going to be this one, and this one, and this one, or this one and this one, which means that we're going to have to calculate, we're going to have to read a lot of values. So instead of doing, when we calculate normals right now, we do it by reading 6 values. But if we would be doing this mesh generation, we would have to read at least we would have to read at least 14 values, and that is too much. Way too much. Any way around that? So if we would be doing it like this, it would probably be better for us to calculate the normals on the CPU, store them in a texture. Then we introduce a shit ton of memory. Bruce, I bet there is a way to traverse everything once and have ready thing. Feels like Sudoku problem where you add value at X and Y into 3 different set, horizontal, vertical, and chunk. Yeah. Like, we have to remember that we're doing all of this on the GPU. It's parallel by design. And the knowledge we have about neighbors is limited, to say the least. When it comes to this approach, the normals is 100% the a very crucial part, and also the parts that fucks it up for us. So it's all about, we're doing deformation on the GPU based on a height map, which means that the whatever normals we send down with the initial mesh, they are no longer true since we're doing displacement. So we need to recalculate them for each vertex. Previously, we always work on a per vertex basis. So that means we only need that vertices neighbors to recalculate the normals. But if we're gonna generate, if we want control over the quads, how they triangleize, and we need more than 1 point, and if so, we need more, we need to calculate more normals. But I might be missing something, some tiny bit of information that makes this possible. Like, this problem would have been so easy, like incredibly easy, if we could feed our geometry shader quads. Okay. I want to know. Let's put topology. Single vertex for point. Actually, if we would be doing it with point, let's see, what do we want to have from by default? We have this mesh. And if we choose to not subdivide it, we send in these points. What if we, for these points, just do bam, 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 bam. Calculate 4 points for each point. But we're gonna calculate this one, and that's one long. So then we calculate these two times, but we calculate the normals for 4 of them. Still a bit better, but definitely not perfect. So then we create these quads and we can choose ourselves if we want to go like that or if we want to go like that. But how would it look if this one is subdivided once? So we get this basically. Then the points we would send in, I think we would like to send in these points then, I reckon. Each point will be calculated 4 times. I think that's a lot of excessive work. Definitely is. But like this point, these points will be calculated. If we end it here, these points will be calculated twice. So you have... that's your... Yeah, at most each point will be calculated 4 times. It's excessive as fuck. I'm wondering, let's do this. Let's see what we have. Geometry shader output. Main. Okay. Main shader output. Let's remove that one and this one. Let's see what we have. If we take a look at the points in question, the ones we're interested in, it's this one right here. We can see here it's these we want to focus on. But I wonder... What if we would just say fuck it to doing quad flips altogether? I want to have... It would be so much nicer if we flipped it like this. Yeah, because it doesn't matter. We need to flip them because eventually we're gonna get stuff that looks like this either way, and that's just painful. Unless... or this. Surface nets? Never even heard of. Let's take a look. Thank you. One sec, let's just see. Okay, let's take a look at this. See what we have. Get... Hmm. Yeah, I'm definitely gonna look into this more, but I'm also wondering, like, how would one go about calculating the normals for these points? Oh, I would love to be able to like analyze the terrain at a closer view, like something like this. I would like to see how it handles slopes like this when subdividing, and if quads are flipped and stuff like that. Like, give me one sec. Like, we're doing something similar, or like this point solution is something very similar as like a first, or my understanding. But yeah, I'm gonna take a deeper look into that after the stream. Definitely. Appreciate the link. Appreciate the link. Mostly interested about the normals, how normals are handled. Because once again, in our case, that is going to be the most. So for instance, if we from our topology do return points, we do get like a grid of points, like maybe we get something like this. Yeah, what's up, Harukanan? Normals are usually the average of the surrounding normals. Yeah, 100%. It could either be, but like, I'm wondering about this specific case. So we have implemented both solutions that take horizontal, vertical, and we have solutions that do horizontal, vertical, and connected. So all connected vertices. And then for even smoother result, you could go all 8 neighbors. The problem is, like, the deeper you go here, or the more precise you want to be, the more performance heavy it becomes. And we're talking about generating multiple vertices from one vertices. So for every vertex we generate around here, they're going to be generated multiple times. And for each of these, we also need to calculate the normals. Yeah. Like, yeah, we displace and we base the normals on the surrounding neighbors. But how the fuck do we do that in an efficient way? Like, together with the support for quad flipping. It's like a problem upon a problem upon a problem. Yo, what's up, Calvino? Found this one-liner in a code review today. But my experience with TypeScript is close to none. Like Hadokanan, let's see if I can explain this in such a way that it makes sense and in a quick way. Like, we have tessellation working, we have recalculation of normals working, and now we have moved on to yet another problem. Like, we improve it in iterations. And the problem we want to fix now is this one you can see right here. So when we displace vertices based on a height map, how the actual visual fidelity of this is very much tied to the topology underneath, right? So we can see here we have a diagonal line like this, then we get something like this, and here we have a diagonal line like this, so we get something like this. What you want to do to fix something like this is that you want to align the diagonal line that triangulizes a quad, you want to align that with the slope direction. So for this one right here, we would like to flip it, right? So instead of triangulating this quad like this, we want to triangulate it like this. Extremely fine detail, but it's very apparent. I wish I could show, maybe I can. We can bring up the snow later on and we can run in a circle, and then you're gonna see that on the parts of the circle that doesn't align with the topology will look like shit, while the corners or edges of the circle that aligns with the topology will look good. So now we're on to a problem of flipping quads. Once again, like, I can't not understate how nice this would be, how easy this would be to solve if our geometry shader could take quads. Or fuck it, I don't even care about quads. If our geometry shader could take triangle adjacent, this would be easy to solve. Unfortunately, geometry shaders can only take point, line adjacent, triangle and triangle adjacent. But it can only take the adjacency options if you don't have a tessellation stage before it. If you have a tessellation stage before it, as we do, you can only take point, line, triangle. So basically, our tessellation returns something like this. Or actually, after our tessellation stage, we just return points. But we work with it as quads. But in our geometry shader, we can only take triangles. So this quad will be sent to our geometry shader in 2 iterations. One iteration will be this triangle, and the other one will be this one. So now the question is, how do we flip this in the geometry shader? We're basically going to have to calculate, so for this triangle we're going to have to calculate this point and do some weird stuff. And for this one we're going to have to calculate this one and do some weird stuff. So already there we have 2 additional vertices. The discussion then was to, what if we focus on middle points? So middle points, we changed the focus on the middle points throughout the pipeline. So if we have this quad and we don't tessellate it, what we send down is this point, this point, this point, and this point, and then we handle it in the geometry shader as points. So basically the geometry shader gets vertices, 1 for each iteration or execution. And what if then we take these points and we ourselves recreate the quads? So we would create quads like this from these points. And since we are creating the quads in the geometry shader, we have full control over if we want to split it like this or if we want to split it like this. And this is very nice. I love this. But what about the normals? We have to make sure. So first of all, one of the backsides is that for every quad we generate, we're going to generate each point twice, pretty much. And some points 4 times. We're pretty much going to generate every point 4 times. So yeah, then you get a lot of... I mean, we do it in parallel anyway, but still. I can overlook this. I can overlook the generation of the same point 4 times, because each time it's connected to different triangles. But we also want to generate or calculate the normals for each of these points, which means that we're going to have to read 4, 6, or 8 neighbors for each of these points. And then remember that for each point, we do it 4 times. We generate each point 4 times. So if we choose to take the simplest way to recalculate normals, it's still going to be 4 times 4, 16 texture reads. Since we're generating vertices close to one another, we might be saved by like the caching and stuff that the GPU does, but still, like what I'm saying is the hardware might actually just read this value once and reuse it. But I don't know if that's something we can rely on. It wasn't very short, but that's pretty much what the whole normal recalculation stuff comes from. You always have the other option of per pixel in the height texture, you calculate normals beforehand. So every time we alter the terrain, or the snow in this case, you go through each pixel in the texture and recalculate the normals, and then you store them in a texture. But that means that we will ever only get a resolution of the normals that is, we can't get finer resolution than the actual height map. And we will occupy, or we will allocate, additional memory. On the other hand, like, I just want to say this again, if we could work with quads in the geometry shader, this would just be as easy as either taking these 3 points and creating a triangle, or these 3 points and creating a triangle. Or rather, either we take these 3 and these 3, or these 3 and these 3. But yeah. I'm also wondering, I don't know. Like, it's a hard problem for sure. And you can see stuff like this in a lot of products, I would say. It's just that I want to get rid of it. So this one would be, just imagine if this quad right here would be split like this instead. It would be a way nicer slope. So instead of having hard edge like this, you would be getting a diagonal edge like this, and you would have this one maybe being a little bit less slopey. Steep, I mean. And this one being a little bit more steep or whatever. It would be amazing. And then I haven't even talked about, where do we have it? This one right here. So here you actually get something that looks like this. And I don't know, I'm having a real hard time selling snow with jagged edges like this. Then again, fuck it, 1 sec. I might be overlooking. Hmm. One sec. Like one could also, I wonder if the triangulation here, these are the original quads. Otherwise, one could think, so if we have an original quad of this, we can actually control how we split them into triangles by telling them how many times we want to subdivide. Or is that true? No, maybe not. Like I always had, also had this idea that in the tessellation or domain shader, actually, I think I went through it at the beginning of the stream. In the domain shader, we get a point here, and we could double check the slope of this one and maybe like switch it with this one, but then we're gonna screw up. So if we want to flip this one, we could switch this vertex and this vertex and this vertex and this vertex. But by doing so, we would screw up neighboring. We swap these, we would be getting a triangle that won't even render because it's actually a line. But and if we do triangle geometry shader, we already have the normal for this one and this one and this one, this one and this one and this one. Yo, what's up, Shub? So what if we, for this triangle, we just take this one and we move it over here, or recalculate we recalculate the normal for this one. So then for this one, we just take this one and move it over here and recalculate the normal for that one. That means that we recalculate one normal per triangle. If we do it in the geometry shader, we won't have. So the triangle that is located here actually don't share the vertex per se. We could do quad flip like this. So then it becomes recalculating 1 point per quad if we decide to flip it. If we don't flip it, we don't recalculate anything. Which might be the best solution yet. Might be the best solution yet. Adding a geometry shader though is probably gonna tank performance as well. But what would we do if we do the last subdivision stage here as well? So we do this swap. So we either have this or we have this. We have only recalculated one normal, right? And then if we do the last, subdivision here as well. So we subdivide once more. Then we get the newly created vertices. Huh. Yeah, this might actually work with the least performance loss. I guess we can try it. Am I missing something? So it's either about moving this one here, or this one there. How can we identify which vertex to switch, and also the direction we want to switch it? Actually, let me do this first. Let's see if we run this. Um, let's do this. Then we just add a geometry shader that basically does nothing except for returning the vertices. Geometry shader output. So I guess we want to do this as, let's just see what we do here. Geometry here. Hmm. What did we get? Then we do it like there we go. And then here we just do... We need to restart strip. Yes, we do. Do we need to instantiate strip? Mm. Triangle stream, no. So then we'll basically just do this. And generate geometry shader output value, input 0, 1, 2. Add vertex, add vertex, add vertex, restart strip. And that's about it. Can we get... One 1.9, 5.2. Actually see... We don't actually see the actual vertex count. We see the vertex count and triangle count of whatever we send down. Okay. Rendering. Can we get... On a vertices 16, indices 36. I want to get some information, like because I see it. Yeah, sure. We create our triangle strips ourselves. So like, if we send down this one to the geometry shader, one geometry pass shader pass works with this one, and another one works with this one. Basically, since we create our strips ourselves, we don't share these vertices. You definitely want to share as many vertices as you can. I don't really know what to think about this. The information we're being presented here. So vertices 16, yeah, that's definitely the original mesh. So no tessellation, no geometry shader. $40. Like if the cost for this isn't too much, we could definitely split it here. What I want to see, so if we go with a solution that does, we're sent this quad, but we're sent it as triangles. So we get sent this and this. We want the diagonal line to be along along the direction with the biggest slope. So I guess we can calculate the slope of, we need to calculate the slope of this one compared to this one. So we need to recalculate this point, and then we compare this slope and this slope. We need to identify where we have this slope. I wonder if we can rely on some sort of order for the input to the geometry shader. Like, is this one always 0, 1, 2? So in this case, can we rely on 0, 1, 2? That's my question. We can probably test that. The only part I hate about this right now is the recalculation of this point. But calculate slope, do a branch. Let's do Bool A. False. True. So always for vertex 2, we set it to be white, the other one's black. Can we see any logic from this? Anything? Mm. Bum 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 bum. Ooh. Nah. No. Okay. What I want to avoid here, but what we could do is calculate distance, distance, distance. The point of interest is always going to be the longest one. That's a lot of branching and calculations. We can choose. The point we're always interested in. Okay, same Y, same X. it's always gonna be I mean, we can do it in a lot of different ways. We have one preferable way. Yeah, we have the diagonal line for the vertices that don't share any coordinate. So this one shares a coordinate with this one, and this one shares a coordinate with this one. But this one and this one has different coordinates both in x and y. That's one way to figure it out. Can we derive this point from that fact? So or can we do it from winding order? Two is here, two is here. No. I don't want to do if this one x is equal to this one x and but we might have to. What the fuck? One sec. We could do... Oh, do we want to do this? We could do it by rotation, around this point. So if we find out that this slope, still gonna figure out this slope. Let's see here. We get the worst type. Let's see. Let's analyze this one over here. Do we have... I'm still questioning this one, actually. Might have overlooked something here. No. The problem we get is that the position of this one is based on this one and this one. Oh. Yeah, what this one would solve is we would get a little bit of a rounded here. Yeah, it would be way better. We don't want the biggest slope. Rotate it. Would look so much better. I want to double check one thing. I want to try... Basically, I want to test if our... I want to test if our points that result from the tessellations are connected between quads. So when we do it this way, each triangle, it's going to be its own triangle, basically. I wonder if we get seams between each quad here as well. What would I output to test that? So pretty much... Need to figure out something we can calculate that would differ between vertices even though they occupy the same position in world, the same position in UV space, the same position in... No. Something like this, but in the domain shader. Yo, what's up, Cooler SK? Yo, what's up, Jax? Still doing some buffer stuff. We're utilizing the buffer stuff this time around. But this specific data is in a texture instead. SK doing better than yesterday. Nice to hear, nice to hear. Slowly but surely converging towards a non-6 state. That's always nice. Yeah, I mean, we are on the right track to performant terrain here. Although we're not using it for terrain this time around, we're using it for a snow shader. But the theory is the same. But now we want to destroy the performance a bit to get some graphical fidelity. We want to get rid of jagged edges. And this, it annoys me a tiny bit that I thought this would be very easy. I made the uneducated assumption that we could work with quads in our domain shader. And it all fell on that tiny little fact. But that's how it is sometimes. We could... Okay, let's do it like... I don't think we could calculate something here that would be different. I'm really interested in exactly how the tessellation does it. So if it tessellates this quad, I'm wondering if this vertex is the exact same in memory as for this quad as it is for this one. I.e., if this one like, I want to figure out if we could create a seam here that is visible by pulling one vertex up, and if there exists two, bring the other one down. Jax, it's kind of boring, huh? I don't think so. I think this shit is interesting as fuck. Quite hard, though. Yo, what's up, Ventrix? Yo, 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 yo. So instead of this edge going like this, the whole goal is, instead of having this edge go like this, bam, getting a sharp 90 degree angle here, we would be getting, bam, bam. We would divide that 90 degree angle edge to a 45 degree at 2 points. Yes. We can do it like this. Bum, 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 bum. We can't do it like... Let's see. Can we? You just generate a random value. Based on... util random, what do we have? Seed. What seed would we use? Time wouldn't help us, I don't think. I don't think we can render the information I want to render. We should be able to do this without it. No, we pretty much need to take... Let's see here. We always need to calculate... One sec. Okay, back. Would it be enough to just split it in half? Now we still need the information of this one. I wonder if I want to... If I just want to try and implement this in the crazy way, i.e. calculating normals multiple times. Just see what we get. See if that works, or if we run into another roadblock. Yeah, why not? I.e. we calculate points here. We don't care about this. We don't care about this. Fuck, it's gonna be brutal, I think. Maybe not too bad, though. It's gonna be a 5x5 kernel here. Or maybe that's not true. What if we do... Maybe it's not going to be that much worse. Actually, we could simplify it a bit. Oh, we could. Huh. Yes, we could. When we calculate the normal for, let's see here. Yeah, we just read these 9 values as we're already reading them. Calculate the heights for the points. And then when we want to calculate the normal for this one, and we want to calculate the normal for this point, we don't have to read any more values. And when we want to calculate the normal for this point, we use yeah, when we calculate the normal for this point, we just use this height difference, and then we do this one and this one. Okay, so if we go, fuck, okay, this might work and be quite performant. Then again, we're going to do this twice, but it's okay. So we do rough normals this time around, i.e. to calculate the normal for one point here, we just take what's above it, what's below it, what's left of it, and what's right of it. And I think we might want to take the distance into account as well. So based on these two, we have shorter distance here than we have here for this point. Then we do the same for this one. Above to the sides. Okay, this might work. This might work. I'm feeling that lovely optimism for the first time today again. But it's going to be a bit complicated. So let's start by, we output points. We output points from our, or we take points as input in our geometry shader. What I'm a little bit worried about now though, what if this one is subdivided once more than this one? Yeah, then we need to calculate. Ooh. It's probably gonna be all right. Let's try it. So what I want to do first, what we're gonna do first, is our tessellation stages, hull shader, domain shader, whatnot, it's going to generate a set of points. Like it already is. It's actually going to generate a quad mesh with some set topology. But the topology information we're just going to throw away. So we're going to get a set of points from our tessellation shader. We process them individually in the geometry shader. So the geometry shader for this point will only know about this point. As in the tessellation shader, we're going to get the neighboring points based on a distance. So we just move getting the neighbor points from the tessellation shader down to the geometry shader. No more calculations right there. And then what we're going to do for this point is, based on the neighbors here, we are going to generate what is it? 8 new points. And we're going to have to calculate the normals of these, but we're not going to focus on the normals first. And for these new points, we are going to base the... we're going to interpolate the height. So this one will have a height... Ooh, that is one decision we will have to make. But we can start with this. So we generate these quads. Or multiple quads. And then for this one, we calculate, is the gradient biggest in this direction? Or is the gradient biggest in this direction? That will decide if this quad will be this quad or this quad. Yeah, let's do it. But then again, yes, this point will be calculated fucking times. If we acquire some nice knowledge during all this, we could minimize that amount by doing this instead. These points will still be calculated a lot, but not these points. I want to try this, and then we can see what the performance is. Go from there, I suppose. Okay, so this is going to be a bit messy. We also lose... That's no problem at all, Ventrix. Okay, we are pretty much going to destroy this whole shader, what we have so far. But we have some version control of it, so it should be okay. So what I want to do first is... I just want to do U vector and tessellation amount. I want to do this. Bam. And then I want to do this. We're gonna do pow to max tessellation max amount. Ventrix doing some active ragdoll networking things, and it's really fun. Yeah, I can imagine. I haven't played around that much with ragdolling in and of itself, but the few times I have, it's been very fun. Okay, so we subdivide the full mesh the same amount right now, because this is gonna add to some of our problems later on. Calculate snow vertex. Joink. Actually, I want to take this one with. And then we put it here. Okay. The good thing about this is that we're always gonna know that these points, they were generated in a previous iteration. These points are the new points. So when we want to do fading then as opposed to popping, we only need to focus on these points, the ones generated in the domain shader. I think we can do some real nice stuff with this. I'm still questioning the performance though, but we'll find out. Do we Okay, I want to keep this as simple as I can. Let's do this. This. And this. The only thing we care about in the output here is gonna be domain shader output. We just care about Position world space. Do we care about this shit? Actually, I don't think we need to send this one down at all, but we can keep this one for now. View direction, UV fog factor. Let's care about these. So we have 6 values. We have all of these here. Position, normal. Let's just rename this one. Position, world space, normal, world space, tangent, world space, by tangent, UV center. Fog factor, let's skip that one right now. And then we do output. Dot position, world space. Something like that. We do have output test. So what I want to do then is we can start by doing point. I guess it is. And then we should be able to just do input. What happens if we do let's wait with this one. And let's do or mm, We need to figure out triangle streams. I hope. Ooh. I think we generate them like this. So how would one go about generating? Could one generate something like this as one strip? Hmm. We can start easy, so we generate 2 strips for this. Dum 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 dum. Although I hate. Can we hide it in one nested for loop? Could we go? So here you want to go. We're gonna go 1. Down. Pretty sure this is how you generate them. So you want to go duh, duh, duh. That doesn't really make sense, does it? Let's take a look what HLSL triangle Steam output 3. Do we have any information? Triangle strip. Triangle strip HLSL. V1. So we want to go zigzag pretty much. So it's gonna be. Is it really though? This is going to be a little bit of a problem when we want to do flip quads later on, but let's see. V1, V2, 3. So what is it? Duh, 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 duh. But let's do it. Bam, like that. Up 1 in Y. So Y, you want Y to flip between 0 and 1, back and forth. And for every full flip, you increment X. So we're gonna have to do this. So we're gonna have to go like this, and then we go like this. And then we go like this. Don't think we can do it in one nested for loop. We're gonna have two nested for loop, and one of them is gonna be 3. So we're gonna have a for loop that do for number of strips, and then inside of that we're gonna have for x, and then within that we're gonna have 0 and 1. Fuck it, we can skip the last one and just add 2 points there. So for each x we add 2 points. Add, add, and add, yeah. But what we need to do first is we need to instantiate the geometry shader outputs. And I want to do it like... Let's call it O. I always forget, so let's take a look. Where do we have it? Okay. Like this. And for each new one here, we want to do O is equal to 1 minus I j minus, or 1 minus j. That's not true, or is it? Yeah, it is. 0, 0, and then we go up to 1. No. We want to do plus 1 minus 1, 0, 0 plus 1, 1. Yeah, something like that. And then we do... would like to be able to do... Let's create one of these. Geometry shader output, generate output, geometry shader output, and we want to send in the main shader output point and float 2 offset, I reckon. Generate geometry shader output point, or actually input. And then we want to calculate offset. Offset is going to be equal to float 2 offset is equal to float 2. And here I want to do I times, and we're going to use test here. Then we do j times test. And that's the offset we send in. highly experimental. But whatever. So then we fill this one up, and then what we want to do is we want to create our triangle streams. So for we wanted to do it like this. Number of strips. X, and then we just add 2. So that makes me wonder if we can do it in here. We'll find out. So here it's basically going to be int I is equal to, we're going to do j is equal to 0, j is less than 3, plus. That's our strip, and then we do int I is equal to 0, I is less than 3, I am plus. At the end of each here, we want to do triangle stream dot restart strip. Here we want to do actually, we just want to go up to 2 here. Because we want to do triangle stream dot append O, and let's see, I j triangle stream and O I j plus 1. So first we would be adding 0, 0. Then we would be adding 0, 1. And we increment this one. So then we add 1, 0, 1, 1. And we increment this one more. So we add 2, 0, 2, 1. And we're done. We'll restart the strip. J is 1 this time around. So we add 0, 1. I think that's correct. And we don't need to do the final restart strip either because we do it here. Something like this. So the only thing we need to do now is generating these points. We have the middle point generated. That's our point. We just need to generate a set of points around it based on this offset. Offset is test. So all we need to do is let's take a look at our output again. We can strip this one down a bit. I don't know if we care about world position. Turns out we do. Care about view direction as well, if we want to get some lights eventually. But what we have to set 100% is position CS. We can set both of these actually. we're gonna cheat with these. We're gonna cheat with this. We're gonna cheat with everything except for the only thing I care about right now is position world space and position clip space. I want those to be good. Hey, what's up, GDs? You done with the snow? Not yet. To get it to a state where I want it, soon TM indeed. To get it to a state I want to get it to, we're probably gonna give it this full week and maybe even the next one. But then we're gonna call it acceptable and move on. I think. But okay, I don't care about anything here except for these two. So what we're gonna do is geometry shader output O is equal to geometry shader output 0. Then we do O dot position in world space is equal to point dot position world space. And we're gonna do it like this: float 3 point position world space dot x plus offset dot x point position yes dot y point dot position ds dot z plus offset dot y. Then we have our position world space. Let's take a look at I want to copy, where do we have it? No. No, 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 no. 498. How am I able to see if that's the, there we go. 498. Yes. So we calculate the position in world space like this, and then we just do O position in clip space is equal to this. But here we do O dot position vs. Okay, a lot of things can go wrong here, probably will. So let's fix the compiler errors first, and then see what kind of output we have. Redefinition of formal parameter UV. Yes. Oh no. Mm. Mm. I'm a little bit worried about this one. That might not be unexpected token point. So tell me. Probably vertex. Mm. We have an example of it here. Geometry shader point input page. Let's 1 sec. Hmm. Hmm. This word right here gives me... I feel some extreme optimism about this one right here. So not point, but point list. Because then we have this. You operate on only one point at a time. Point list. Okay, so it's a list with one index. Fuck. I visualized me having a point list of 4 indices right here, i.e. a quad. But what the fuck? Line list or line strip? I would love some more information here. Ooh. Line strip. I'm just trying to look for things, or triangle strip. Maybe there actually exists a better way to do this. Point. You operate on only one point at a time. A line requires 2 vertices. Triangle requires... Okay. Let's see, remarks. The following vertex, winding direction. Oh, love this one. Input vertex, element. So I guess the secondary index here is for when you do adjacent stuff. Yeah, probably. But I'm still very much intrigued by this. Triangle strip. Yo, what's up, Catboy King? This one. Is it even possible to send onwards a triangle strip from a tessellation shader down to a geometry shader? Invocations from tri-strip with adjacency. Jesus, look at this. With adjacency. Could I get triangle strip without adjacency? Generated by input assembler. If we could send in a strip. God. I'm just trying to cheat my way into sending quads to my geometry shader. Okay, I just need to see, do we get some nice quick results for HLSL, Tessellation, shader, output, triangle, rip, to geometry, shader. How fucking sick would this be? Tessellation and geometry shader with what? Tessellation and geometry shader with GL triangles adjacency. It's GL, we work with adjacency. So we're going tessellation to geometry with adjacency. It doesn't work in HLSL. Don't think it works in OpenGL either, but we'll see. No answers. Nah. If we go EC, tessellation, HLSL, output, triangle, strip. I love these. Triangle, strip. Triangle, strip. Yeah, okay, no quick answers, but I might do some search later on, but this would be insane. Although so basically if I'm allowed to fantasize a bit, which I do like to do, it would be, we have this initial quad, we tessellate it a few times, tessellate it like this, maybe. We get triangles like this, maybe, and so on. So then in the geometry shader, instead of sending down one point, one line, one triangle, instead we send down one row as a triangle strip. If this would be possible, it would be extremely easy. So then we just go through the two first triangles. Do we need to flip them? If so, we do. Then the next and the next. But I don't know. It wouldn't surprise me if we work by the same rules as adjacency when it comes to triangle strips, i.e. it doesn't work. You can't go tessellation geometry shader with adjacency. Yeah. Stream output object. Is this if you want to do geometry shader to another geometry shader? So you can get triangle strips as input if you have another geometry shader. If that is true, our first geometry shader can take triangles. Maybe we could do something. And add them. Point stream, line stream. Because, okay, a stream output object is a template object that streams data out of the geometry shader stage. So we probably can't go tessellation strip. But we're gonna have to do tessellation, geometry to takes triangles, and then we add a second geometry shader stage. How weird would that be? I don't even know if it's possible. Maybe. Interesting. I wonder if we could do some hacky stuff with this knowledge. But anyway, let's keep that in mind and move on to triangle strip. Oh yeah. I wanted to check point. Yeah, so I think maybe the only problem or the only issue we have here is that we haven't specified that this is a, not here though, but here, that this one is a 1. And we do 0 here. No, unexpected token point. Isn't it like this? Or have I generate no matching to pair? Okay, it's probably this one then. I need to change max vertex count here as well, but and no matching one parameter. How much version used where a vector constructor may have been intended? Not all control paths return a value in... Yes. Okay. So what do we have here? Geometry, this variable, blah, blah. The compiler can always detect that an array is fully assigned to fully initialize the array in the declaration. Shit out. I don't care about that one right now. Yeah, so how the hell do we initialize this one fully? Okay, so it just prints the same error multiple times. Nah. We don't have a known size. What if we do roll? Does it understand it then? No. Okay, for this one, I just want to do this right now. HLSL instantiate empty array of set size. Oh, come on. Or fuck, can we do... Ooh. Ooh. Oh, okay. And then we do... And then we do... this is how it looks when we do no tessellation. Not perfect. Definitely not perfect. I want to see test. It's something. Okay. No insane FPS drops just yet. But what we have here is it's interesting. Although I wonder what the fuck is happening here. I would like to see... Okay, so what do we have? We have a... Let's go with subdivision of 1. That means that we subdivide it 2 to the power of 1 with 2 times. So each of these should be... Should get 1 point here, 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 and here. Here, and here, and here, and here. That's not what I'm seeing. And then have I misunderstood? Hmm. What I'm seeing here is we're getting, with a subdivision of 1, i.e. 2, we're just getting 4 points, or we pretty much just send down 4 points to this one. Why do we only get 4 points? It's like we skip this point, this point, this point, this point, and this point. We're doing 1 less. Yeah, we're just doing 0, 1. We're doing 2 stripes, but we should be doing 3 stripes. But if we set this one to 2, we get too much here. Actually, but we're not getting these either. Yeah, we're only getting 2 stripes, that's for sure. Out of bounds, yes. But 1 sec. We just do 0 and 1 here. 1, we get to 2. Should be doing this one as the first and this one. What's up, Enzo? Looks exciting. Yeah, I think so. We're missing these and these points. What am I not getting here? Zero, 1, 2. No, I think we're doing this correct. We're doing... It's basically just this one, right? This is one strip, this is one strip, this is one strip, this is one strip. We don't get sent enough information from this one. Why is that? Let's minimize these a bit. Or no. These strips should be greater, right? Okay, let's go with 1, 0. So we have... These are the original vertices. We skipped these for some reason. So we get a little bit of an offset. And we get one more. I reckon this is the closest to what we get. We get this point, this point, this point, this point, this point, this point. So if we would just get so right here, right at this example, we are missing 3 quads per original quad. I would love to see, I'm just gonna double check the tessellation and see if that one is wrong. So let's skip geometry and do the main shader output. Anything? Oh yeah, of course, because we need to do there's one thing we want to fix here is 2 to the power of tessellation amount. Why are we getting a fade like this? Ah. Yo, what's up, Diligence? Looks okay. So the tessellation is okay. Let's add geometry shader back. Diligence, what GPU you got, Robin? At 1080 in this computer. Okay, we're always losing the last set of points. Is that the case? 0.85. So then I guess if we go up to 2 or 3, and we do minus 0.125, 0. What is it? 4, 375, 85, 95, 4. To 5, something like that. No, not really. There we go. Yeah, we're always losing the last set of quads. Why? Diligence, the classic 1080. Yeah, it has. It's amazing. Simply put, it's been working for me for a long time. Diligence looking out for a new desktop, but GPU prices are ridiculous here. Yeah, I'm not too far from you, right? They are ridiculous here as well. It's insane. Nvidia is doing their thing, and I guess gamers or game devs are not the main customer anymore, put it mildly. But let's see. What's up? What's up? What's up? What's up? Yeah, we would like to do. Huh. Yes, so when we get a point, we want to go upwards. Oh, yes. And we want to do it. I made a mistake here. When we get a point, No, I just made the wrong assumption. We can see here by rescaling these, they only rescale in one direction, right? Bottom left. First of all, I would assume that we would get more than one or more than two triangles. And if we scale that one, I would like to see it go both up, or it should scale relative to this point. So if we do, yeah, it's easiest to work with this one. 1, 2, 3, 4. 1, 2, 3, 4. We're not getting the last set here. And we don't want to. This one we want to scale to fit this. Ooh. One sec, I want to see. Let's bring this one up a bit. Performance, don't care, nice. Let's go 6. Can I go to max here without it crashing? Yeah, we should probably be at max here. This one don't care, that's good. 3.5 milliseconds. So what am I missing in my calculations? Diligence, are you optimizing or now we're trying to get rid of like we have a quad-based mesh which we displace given two textures, a height map and a activity texture. And when you have quads being turned into triangles, you want the split to be aligned with the slope. Pretty much you get a much nicer, smoother mesh if you do that. And we're trying to fix that, but we have taken a few steps back. We've taken a few steps back to fix it. I'm outputting sound here, so that should be on your side, Diligence. Hear me? Pretty sure we're doing something wrong here, or I'm doing something wrong here. I'm a little bit worried about this one, but it shouldn't be that one. We should be creating 9 vertices. We should... And so why is it less than 3 and J less than 2 in those? So here, we're creating triangle streams here, or triangle strips. So it's pretty much, we want to create this quad, and this quad consists of 2 triangle strips, this one and this one. So that's the outer loop. It could be wrong. And the inner loop here is looping this vertex, this vertex, this vertex. So we're pretty much creating the triangle strips by looping, or by traversing it like this. This one should be like this, by the way. So we're doing it like this, 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 this. That's our first strip. Then we do it like this, 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 this. That's our second strip, but might be something wrong here. Diligence, hope you hear me now. The short you made look beautiful. Thank you, appreciate it. And that's pretty much what we're in the process of doing right now. We're gonna make it look even more beautiful eventually. But it's a lot that needs to be fixed before we can do that. Yes, we don't. We want to output more than 4 vertices this time around. We want to output. So we're working in quad fashion. Like I said, we want to output 1, 2, 3, 4, 5, 6, 7, 8, 9 vertices. I wonder if we need to count these twice. Let's see. So let's change that one to a 9. Okay, we need to count those twice. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Are the compiler happy? Yes. And now we scale from the middle and we get this eventually. 1, 2, 3. Yeah, we missed this one. would probably like to not do these and move all of these up. But yeah, or we should be getting these. Okay, if we have a subdivision that is not 0, we're fine. We're gonna have to handle that specific case. And this one is 10 by 10, 1.575. Yeah, we're gonna have to calculate the exact length we want of these as well. Which I find out to be a little bit weird. It should be... wonder if it's... I wonder if it's 2 minus 0.25 minus 0.125. 1.625. That's a little bit too small. Or is it 2 minus 0.5 plus 25, or actually 2 minus 0.25 minus 0.125. Or no, 1 minus 0.5. No. 2 minus 0.5 plus... I'm trying to find the logic here to make these, because basically when we generate this vertex, we want to generate it. This and this should meet at the exact same spot. And I want to try and figure out what that is. 5, 6, 7, 5. No. What is the logic behind that number? Okay, now we're close to crashing here, I reckon. So I take that as the performance is tanking. But that could be... yeah, one sec. The depth testing we get when we have so many overlapping... so let's bring this one down again. There we go. And then let's minimize this one to here. And then we bring this one up. Don't like this at all. Fuck. As long as we don't have any overlap, we get good performance. As soon as we... yeah, we get pretty good performance. That's good to know. If we do 2... and we bring this one up. But still, we're losing the outermost for some reason. But I wonder if we do... As long as we don't do overlap, seems to be okay. But what's going on here? $280 is good. We're not doing too heavy stuff. The fact that we're not reaching the edges annoys me a bit. Also find it weird that this is not... Okay, actually... Yeah. For some reason we don't get sent... We don't get sent the vertices on the edges here. Or we are, but no, we're not. Should have one quad here, one quad here, around the whole thing. And that's also something I haven't quite taken into account. So if we get a point here, we generate a quad here, we're fucked because we're gonna have overlap here. Although I do love the quads we get, so they are always aligned or split as bottom left to top, no, bottom right to top left. That would simplify stuff. I don't know. I wonder if we could hack it by doing... And so that's weird how you get 2n-1 quads, yeah. Something happens with our quads that are positioned at u equals to 0 or 1, or y, or v equals to 0 or 1. It's pretty much like we... In our domain shader, we take points. Points we get from tessellation. Now, I would assume that we would be getting quads here as well. Overlapping quads here. Actually, I know what it is. Do I? No, I don't. You know what? I'm gonna have to run now, unfortunately. And I'm pretty sure I need to get back to school. I need to research this quite a lot. Hopefully I will find the time today. Otherwise, I don't know what I will do tomorrow. I love this experimentation. And I like what we're doing here. I think the end result is going to be great, but it just feels like at every approach we take, we run into a new problem, a new constraint that fucks it up for us. In short, I'm going to do my best to be prepared for tomorrow's stream and have a clear way forward. Not entirely sure just yet if I like the idea of introducing a geometry shader stage here, but it might be our only option. We'll see. Thank you all for watching. Appreciate you, and have a great rest of the day. Peace.